Okay, guys, I apologize that I got interrupted at the end of explaining this. I actually had a special guest, Mr. Cowen, is here in the room, along with his sister, Mrs. Jackson. Yes. She's here, and they're going to help me finish up this last problem. So it asks, how would lowering the energy of activation affect the rate of this reaction? So, Mr. Cowen, how would lowering the energy of activation help the rate? What would it do to the rate?
Increase the rate?
Yes, good job.
Yeah.
How would you explain to a third grader how lowering the energy of activation increases the rate?
I would, if you look at the curve, to a third grader, I'd liken it to pushing a ball up a hill, right? So
very good. Okay.
The ball would go to the very top, like that's the first energy. But then if we lower the activation energy, that makes the hill shorter. So, a third grader, like all you guys might be able to figure out from this. It's a smaller hill, so it's going to take less energy to push it up, right?
Very good.
And you also be able to do it quicker.
All right, class. We're gonna ask Mr. Cowen a tricky question now. Mr. Cowen, how would lowering the energy of activation affect delta G? How would it change?
G.
How would it change the spontaneity?
I don't know. Do we have any equations I can refer to?
Yeah, actually, delta G equals delta H minus T delta S.
All right. So delta H being enthalpy, and delta S being entropy.
Good job.
All right, and so we're lowering the activation energy. Oh, and that's going to change our delta H on the left side, right? Is that what it does?
No, Mr. Cowen. Delta H is actually just the difference between where you start and where you end up. So, so we know that this is not changing.
Okay. And does our temperature change?
Definitely not. No, temperature's happening at the same.
So now our entropy. Entropy. It's not really. That doesn't change either, does it?
No.
So we're not changing how messy or clean it is. So delta G won't change.
That's awesome. All right, this is perfect. No effect on delta G. Just because the reaction happens fast, it doesn't really talk about if it happens.
It's just the speed, not whether or not it's going to occur.
Yeah. So if something happens, it has nothing to do with how fast it does. Ice could melt spontaneously slow at 1 degree Celsius, but spontaneously fast at 100 degrees Celsius. So, very good job.
Well done, everyone.
Yeah. Yay! Shout outs to Mr. Cowen.
Yeah.
Thank you very much, Mr. Cowen. We appreciate it.